Alright, Chapter 6, Section 5, Factoring Binomials. Alright, the last part of factoring for this chapter. Okay? And what you need to see here on all of these problems, okay, if you have a term minus a term, okay, so there's just two terms instead of the normal three that we saw in Chapter 6, Section 3. If the first term is squared, the last term is a perfect square, and there is a minus in between. It's got to be a minus. Then it's going to factor into the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Okay, so I'm going to show you how it works, and we'll talk about y in a second. X squared minus 25. X squared is a perfect square. 25 is a perfect square. So this is going to factor into x, because x is the square root of x squared, plus the square root of 25 is 5, and you're going to have another parentheses, the same terms except there's a minus in the middle. And that's it. Okay? Now the reason why is because when you multiply this back through there, x times x gives you the x squared. X times negative 5 gives you a minus 5x. 5 times the x gives you plus 5x. And 5 times the negative 20, or 5 times the negative 5 gives you the minus 25. And then you'll notice that the two terms in the middle are the same term except with opposite signs, so they actually cancel out to 0. And you're just left with the first term, the last term, and a minus in the middle. Okay, so that's the reason why, but it's really pretty quick and straightforward. So example 2, got multiple problems on here. A, I've got 4x squared minus 1. All right, the things you're looking for are both the terms perfect squared. 4, that's 2 times 2. X squared is x times x. 1 is 1 times 1. Is there a minus in the middle? Check, that also works. So you're going to factor it into 2x, because that's the square root of 4, square root of x squared, plus 1, and then 2x minus 1. All right, B, I've got 25a squared minus 9b squared. 25 is 5 times 5. A squared is a times a. 9 is 3 times 3. B is b times b. So yes, this is perfect square. There's a minus in the middle. So 5a plus 3b times 5a minus 3b. All right, C. Try to trip you up with a fraction here. But again, y squared is y times y. 4 over 9, it's a fraction, but if you just look at the top, 4 is 2 times 2, 9 is 3 times 3. So it is a perfect square. So it factors into y plus, since 2 times 2 is 4, we put 2 on top. Since 3 times 3 is 9, I put a 3 on bottom. So it gives you y plus 2/3 and y minus 2/3. All right. Hopefully these are the problems that you can just do really quickly and make sure you get those right on the test. All right, example 3 makes a little strange here. I've got x to the 4th minus y to the 6th. All right, so if you have exponents that are not just 2, as long as those exponents are even, you still have a difference of 2 squares. Okay, so what you're going to do is you're going to break out into your binomials, and you're going to divide the exponent by 2. So 4 divided by 2 is 2. So I'll have x squared and x squared. 6 divided by 2 is 3. So I'll have y to the 3rd and y to the 3rd. If you were to multiply that back through there, when you multiply, you add exponents, so that does give you the 6. And then since it's a difference of two squares, I got a plus, and I've got a minus. All right. Helpful hint up at the top that we talked about in the last section as well. You got to make sure that if there is a greatest common factor between them, you take that out first. All right. And other than the GCF, the sum of two squares cannot be factored. The sum of two squares cannot be factored using real numbers. So we always have to have a minus in the middle. And then finally here, factor completely. And we'll see that on A here. On A, I got y the fourth. That exponent is even, so I'm good. 16, that's 4 times 4. That's a perfect square. There is a minus in the middle. So this turns into y squared plus 4, y squared minus 4. All right, now that's where we stopped on all the other problems. Okay, but if you look at what you have left over, the y squared plus 4, I cannot do anything with that because there is a plus in the middle. That does not factor. But that second parentheses here, we have another perfect square minus a perfect square. So that's going to turn around and factor into y plus 2, y minus 2. And since there's no more perfect squares going on, I am factored. All right, so helpful that if you see something raised to the fourth power minus a number, a lot of times it's going to be this, where you do the difference of two squares once and then do it again another time. All right, B, x squared plus 4. I do have perfect square and perfect square, but since there's a plus in the middle, this thing will not factor. Will not factor. Okay, so this one is not factorable. You can't do anything to it. Okay, it doesn't break down at all. All right. Now the GCF part. Okay, if you look at examples 5 and 6 here, as they're written, they are not difference of two squares. Okay, but on number 5, you look and see, hey, both of those terms have an x in them. So if I factor out an x first, again, GCF do that first, that gives me 4. Now it's x squared because I took one of the x's away. And instead of 49x, I have minus 49. So I've got the x hanging out in front, and then that parentheses there is 4 is 2 times 2, 49 is 7 times 7. So this will factor into 2x plus 7, 2x minus 7. Again, perfect square, so you take the square root, put it in the front, take the square of the last, put it at the last, and you're going to have one parentheses with a plus, one parentheses with a minus. All right, example 6. Again, 162 and 2 are not perfect squares, but if you factor out, divide out a 2, when you divide 162 by 2, you get 81. So I get 81 x to the fourth minus 1. All right, now 81 is a perfect square, so I can rewrite the 2. Square root of 81 is 9. X to the fourth will go down to x squared, and I'll have plus 1, 9x squared minus 1. All right, but always look when you get done, is there something else I can do? And that last parentheses there, I'll actually factor again, because 9 is 3 times 3, x squared is x times x, and 1 is 1 times 1. So you'll have the 2 that you already had written down. You'll have the 9x squared plus 1. And then the minus 1 will factor into 3x plus 1, 3x minus 1. That's it. All right, so the final example here. If there's a minus at the very beginning and there's a plus in the middle, all right, you have two options here that I see you can do. All right, one option is to factor out that negative 1 like we've done before. If you factor out the negative 1, this turns it into 49x squared. So the 49 will become positive. And since the 16 was positive, but you factored out a negative, it'll become a negative or minus. And then when you factor that difference of squares, negative 1's hanging out in front. Square root of 49 is 7. With the x, the square root of 16 is 4. So 7x plus 4, 7x minus 4. All right, and there is one way to write your answer. Okay, another way you could possibly do it. All right, if there's that minus in front of the first term, you could just switch the order. You could turn this into 16 minus 49x squared. And then you see perfect square minus perfect square. And you can factor it out like this. Square root of 16 is 4. Square root of 49x squared is 7x. And so you'll have 4 plus 7x, 4 minus 7x. All right, and so that would also be an acceptable answer. Either way, whichever one you like. All right, again, I'll post the work notes on Canvas. If you want to come to class early next time before our test, ask questions if you need any extra help.